Hello everyone. Today we are discussing about L2 regularization. Let's first discuss about the overfitting briefly. Overfitting means that your model learns too much from the specific data you have and fails to generalize well to new or unseen data. This can lead to the poor predictions and low performance. Regularization helps you avoid overfitting by adding a penalty term to the cost function of your model, which measures how well your model fits the data. The penalty term reduces the complexity of your model by shrinking or eliminating some of the coefficients of your input variables. There are two types of regular, but the most common ones are L1 and L2 regularization. L1 regularization adds the absolute value of coefficients to the cost function, while L2 regularization adds the square of the coefficients to the cost function. Both types of the regularization have a parameter called lambda, which controls how much penalty is applied to the coefficient. A higher lambda means more penalty and more shrinkage, while a lower lambda means less penalty and less shrinkage. You can choose the best lambda value for your model by using the cross-validation, which is a technique that splits your data into different subsets and evaluates your model on each subset. Now let's regularization in logistic regression. Let us know about the logistic regression briefly. Logistic regression models are based on a mathematical function called as the logistic function, which is also a sigmoid function, which maps any input value to the number between 0 and 1. The coefficients of the input variables determine how much each variable affects the output of the logistic regression. However, some of the coefficients may be too large or too small, which can cause overfitting or underfitting. Overfitting means that your model is too sensitive to some variables and ignores the others, while underfitting means that your model is too simple and misses important patterns in the data. Now, the regularization helps you balance the trade-off between the overfitting and underfitting by adjusting the coefficients too. This is the loss function of the logistic regression. The loss function must be minimum for the beta model. So, we function to make it the loss function minimum. Here we can arrive at two cases for the class label 0 or the class label 1. The class for class label 0, it will tend the WI value to minus infinity, and for class label 1, it will show the WA value to plus infinity. So we use the L2 regularization. The new loss function for applying the after applying the regularization is shown in the below, where lambda is the regularization parameter and also a hyperparameter which controls the trade-off between the two goals, fitting the trained data well versus the keeping the parameter small to avoid. Now let's just discuss the benefits of using the regularization in logistic regression. Regularization can improve the performance and accuracy of your logistic regression model by reducing the overfitting and underfit. Regularization can also help you deal with the multicollinearity, which is a situation where some of your input variables are highly correlated with each other. Multicollinearity can cause instability and inefficiency in your model as well as misleading interpretations of the coefficients. Regularization can reduce the impact of multicollinearity by shrinking or eliminating the coefficients of the correlated variables. That's it for today of discussing about the L2 regularization in logistic regression. Thank you for watching. Bye.